Hello friends, welcome back to my channel Maths by Samit Deshmukh. In this video, we are solving question number 5 from exercise 1.3. So let us begin with the first example from this question. Here one function is given to us, log of x plus y is equal to log of xy plus p, where p is nothing but constant. We have to differentiate it and we have to show that its derivative will be equals to minus y square upon x square, means we have to show that value of dy by dx is equal to minus y square upon x square. So here we have considered the given function. If you observe the given function, this is logarithmic function, and in case of logarithmic function, first we are trying to simplify it using laws of logarithm, and later on we will differentiate it using our standard formulas. So let us first simplify it. So on this side we does not have a law for log x plus y, so keep log x plus y as it is, but we know that log x into y can be written as log x plus log y. Constant term p, keep it as it is. Just this term we are simplifying using laws of logarithm. We know that log a into b can be written as log a plus log b. In the same way, log x into y can be written as log x plus log y. Now we are differentiating it with respect to x. So differentiate it with respect to x. So it is in the form of log f of x, and we know that derivative of log f of x is 1 upon f of x. What is the value of f of x here? X plus y into derivative of f of x. F of x, just now we have seen that it is x plus y. Now on this side, derivative of log x will be equals to 1 upon x. Derivative of log y, instead of x if any another term appears, we will consider it as what? F of x. x के जगह पे कुछ और चेंज होके कुछ एक टर्म आ गई, that if x is replaced by any another term, at that time we will consider it as what? F of x, means it is in the form of log f of x. Its derivative is 1 upon f of x. What is f of x? Y. So its derivative is 1 upon y into derivative of f of x, means derivative of y is dy by dx, and lastly derivative of this constant term will be equals to 0. Here we can observe that only the remaining part is to find out differentiation of this term. So here 1 upon x plus y, keep it as it is. Now derivative of x will be equals to 1 and derivative of this y will be equal to what? Dy by dx. On this side 1 upon x, keep it as it is, plus 1 upon y dy upon dx also as it is, not necessary to write 0. So differentiation is completed. Now remaining part is just to simplify it and try to get our required result. Okay, so let us simplify it. First I am multiplying by 1 upon x plus y to both the terms in this bracket. Multiply to first term. 1 upon x plus y into 1 will be equals to 1 upon x plus y. Now I am multiplying to the second term. Let us see what we'll get here. So 1 upon x plus y into dy by dx is 1 upon x plus y dy by dx. On the right hand side, 1 upon x plus 1 upon y dy by dx, keep it as it is. Now since we have to find out the value of dy by dx, so first collect the terms of dy by dx. How many terms of dy by dx are there? 2 terms. We are collecting the terms of dy by dx on left hand side. So 2 terms of dy by dx are there. We are taking dy by dx common from these 2 terms. Here its coefficient is 1 upon x plus y, and if you observe this term, ये term plus है, ये side में आके क्या होंगी? Minus. So minus 1 upon y and dy by dx we have taken common, means from these 2 terms we have taken dy by dx common. Now write down remaining all terms on the right hand side. Already on the right hand side 1 upon x is there, and this term 1 upon x plus y on this side will become minus 1 upon x plus y. Now let us simplify it. So on the left hand side we are taking cross multiplication. Let us see, y into 1 will be equals to y, and x plus y into minus 1 will be equals to minus x minus y, and in the denominator y into x plus y. Just simply here we have taken cross multiplication, keep this dy by dx as it is, into dy by dx. On the right hand side also we are taking cross multiplication. X plus y into 1 will be equals to x plus y, and here x into minus 1 will be equals to minus x divided by x into x plus y. So here x plus y and x plus y on both sides will get cancelled. Now simplified, check that in the numerator here easily we can observe that plus y and minus y will get cancelled. Remaining term in the numerator is minus x and in the denominator is y into dy by dx. Keep it as it is on this side. After cancelling plus x and minus x, remaining term in the numerator is y and in the denominator is x. So this implies that dy upon dx will be equals to, now y will get multiplied on this side, so y into y will become y square, x will get divided, each side में multiply इधर divided होगा तो x into x will become x square and keep this minus as it is. Means in this way we have shown that value of dy by dx is equal to minus y square upon x square, which is nothing but our required value. Now observe the second example. In this case, one function is given to us, log of x cube minus y cube divided by x cube plus y cube to the base 10 is equals to 2. Using this, we have to show that value of dy by dx is equal to minus 99x square divided by 101 y square. So first we have considered the given function. Now before differentiating it, let us simplify it, and to simplify it we are using laws of logarithm. So let us revise once again the definition. We are applying definition of logarithm. So let us revise the definition of logarithm. So if the given function is in the form of log of b to the base a is equal to x, then this is such type of representation is called as logarithmic form, and we are trying to convert this logarithmic form in terms of exponential form. Now here what is base? Base is nothing but a raised to power x, whatever may be the value of logarithm is there, that is nothing but exponent will be equals to b. Now means using definition of logarithmic function, logarithmic form can be converted in terms of exponential form using this definition, or exponential form can be converted into logarithmic form. As this stand we are converting logarithmic form in the form of exponential form, so which is equals to, now what is base here? A. So here base is nothing but what? 10. So base is nothing but here 10. So 10 raised to power x is nothing but exponent, here value of exponent will be equals to 2, and b, log of b is nothing but this, log of b, this is nothing but b here, means x cube minus y cube divided by x cube plus y cube. Just we have converted logarithmic form in terms of exponential form using laws of logarithm. So 10 square can be written as what? 100 also. So on this side x cube minus y cube, keep it as it is. Now x cube plus y cube will get multiplied with what? 100. So 100 into x cube plus y cube will be equals to 100 x cube plus 100 y cube. Now we are trying to collect the terms of x cube on one side and y cube on another side. So here x cube, keep it as it is, and this 100 x cube on this side will become minus 100 x cube, and on this side 100 y cube, keep it as it is, minus y cube on this side will become plus y cube. Just simply we have collected the terms of x cube on one side and y cube on what? Another side. Now we are trying to simplify this expression, and later on we will differentiate the simplified form. Okay, so on this side x cube minus 100 x cube will be equals to minus 99 x cube, and on the right hand side this addition will be equal to 101 y cube. Okay, so here already now the given function is in the simplest form. Let us differentiate it. So differentiate it with respect to x. On this side minus 99, keep it as it is. Derivative of x cube, first take the power as an coefficient and decrease power by 1. So in this way we have got the derivative of x cube. Now on the right hand side 101, keep it as it is, 101 as it is. We are differentiating y cube. So first take the power of y as an coefficient, then decrease its power by 1 into derivative of y, means dy by dx. If you observe both the side very carefully, so 3 and 3 on both side will get cancelled. Remaining term on the left hand side will be minus 99 into x square, will means minus 99 x square, and on the right hand side 101 means 101 y square into dy by dx. Now nothing is there to simplify, just try to simplify it so that we will get our required result. So this implies that dy upon dx will be equals to, on this side minus 99x square, keep it as it is, and here 101 y square will get divided on this side, so 101 y square, and check that is it our required result. In this way we have got the required value of dy by dx. Now see the example number 3rd. In this case, one logarithmic function is given to us, log of x raised to power 4 plus y raised to power 4 divided by x raised to power 4 minus y raised to power 4, and to the base 5 is equals to 2. Using this, we have to show that this is nothing but value of differentiation. So first we will simplify this logarithmic function using definition of logarithm, which we have applied in the first example also. Again, let us revise the definition. So log of a to the base b will be equals to x. Then such type of representation is called as logarithmic form. We are trying to convert it in the exponential form. So what is b here? B is nothing but base, x is nothing but exponent, and a means if we are writing this logarithmic form in this way, so this representation is called as what? Exponential, because here x is nothing but exponent. Value of logarithm is nothing but always the value of exponent. So if you are writing it in this form, then such representation is called as what? Exponential form. Using the definition of this logarithm, we are trying to convert this logarithmic form into exponential form. So here easily we can observe that base is nothing but 5, power is nothing but 2, and log of a this is a is here what? X raised to power 4 plus y raised to power 4 divided by x raised to power 4 minus y raised to power 4. Just we have simplified it using the definition of what? Logarithm, which we have studied in class 11th. Now simplify this function, and later on we will differentiate simplest form. So here square of 5 is nothing but 25. On this side x raised to power 4 plus y raised to power 4, keep it as it is. This denominator will get multiplied with minus 25. So let us see what multiplication we will get. 25 x raised to power 4 minus 25 y raised to power 4. ये जो डिनोमिनेटर इधर 25 को मल्टीप्लाई हो गया, तो हमें ये रिजल्ट मिलेगा. So now we are collecting the terms of x square on one side and y square on another side. So this y raised to power 4, keep it as it is, minus 25 on y raised to power 4 on this side will become plus 25 y raised to power 4, and on the right hand side collect the terms of x. 25 x raised to power 4, and this plus term on this side will become minus x raised to power 4. So simplified, 25 y raised to power 4 plus 1 y raised to power 4 is 26 y raised to power 4, and on this side 25 minus 1 will be equal to 24 x raised to power 4. Just we have collected the terms of x raised to power 4, and on left hand side y raised to power 4. Here easily we can observe that both the sides are divisible by 2. If I am dividing to left hand side by 2, here we will get 13 y raised to power 4, and if I am dividing to right hand side by 2, so here we will get 12 x raised to power 4. Just simply we are dividing both side by what? 2. Now the function is in the simplest form, so let us differentiate it with respect to x. So here 13 is a constant term, keep it as it is. Derivative of y raised to power 4, first take the power of y as an coefficient, decrease its power by 1, and then derivative of y is dy by dx. So, and on the right hand side 12 is a constant term, keep it as it is. Derivative of x raised to power 4 is 4x cube, just simply taking power as an coefficient, decrease power by 1. Now easily here we can observe that 4 and 4 on both sides will get cancelled, so which implies that dy upon dx will be equals to, because our required value is nothing but dy upon dx, so we are trying to find out value of dy by dx. So on the left hand side 12x cube, keep it as it is. What is coefficient of dy by dx? 13y cube, which will get divided on this side, 13y cube. In this way we have shown that the value of dy by dx is equal to 12x cube divided by 13y cube. See, in the example number 4th, we have to show that e raised to power x plus e raised to power y is equal to e raised to power x plus y. Using this, we have to show that dy by dx is equal to minus e raised to power y minus x. So we have to show that this will be our required value of dy by dx. So to find out differentiation, first we are considering the given function. So here let us differentiate it with respect to x. So nothing is there to simplify, that's why we are differentiating it with respect to x. Already the given function is in the simplest form, means nothing is there to simplify. So derivative of e raised to power x is e raised to power x. Derivative of e raised to power y means it is in the form of e raised to power f of x, and its derivative is e raised to power y into derivative of y is dy by dx. On the right hand side, derivative of e raised to power f of x is e raised to power f of x into derivative of f of x. What is f of x here? X plus y. Okay, so just we have applied our standard formulas to find out differentiation. Now e raised to power x, keep it as it is, plus e raised to power y dy by dx also as it is. On this side, e raised to power x plus y as it is. Now we are finding differentiation. So what is derivative of x? 1, and derivative of y is dy by dx. So here we can observe that differentiation is completed. Only the remaining part is to simplify it to get our required result. To simplify it, first I am multiplying by e raised to power x plus y to both the terms in this bracket. E raised to power x plus y into 1 is e raised to power x plus y. Now I am multiplying to second term. So we will get e raised to power x plus y into dy by dx. Right hand side, left hand side, keep it as it is, e raised to power x plus e raised to power y dy by dx. Since we have to find out the value of dy by dx, means our first aim is to collect the terms of dy by dx. How many terms of dy by dx appears here? 2 terms. So if I am taking dy by dx common from these 2 terms, so let us see what we will get. In short, we are collecting the terms of dy by dx. So here its coefficient is e raised to power y, and minus this term on this side will become minus e raised to power x plus y. On the right hand side, e raised to power x plus y, keep it as it is, and this plus e raised to power x on this side will become minus e raised to power x. In case of implicit function, one aim is to collect the terms of dy by dx on one side and remaining term on the another side. So now find out the value of dy by dx. So therefore dy upon dx will be equals to, on the left hand side, e raised to power x plus y minus e raised to power x, keep it as it is, and this term will get divided on this side. So means what will get? E raised to power y minus e raised to power x plus y. In this way we have got the value of dy by dx, but this is not our required result, isn't it? Means to get our required result we have to simplify it, and here it can be simplified using laws of logarithm also. It is in the form of a raised to power m plus n, but applying laws of logarithm we are able to, sorry, not laws of logarithm, laws of exponent. Using laws of exponent we are able to simplify it, but not able to get our required result. That's why we are using this condition, given condition, to simplify it. According to this given condition, what is the value of e raised to power x plus y? E raised to power x plus e raised to power y. So here this term, new e raised to power x plus y, can be replaced by e raised to power x plus e raised to power y minus e raised to power x, keep it as it is, substitute the same value in the denominator, e raised to power y, keep it as it is, minus also as it is, and now replace e raised to power x plus y by its value. What is its value? E raised to power x plus e raised to power y. This value I am substituting from equation number first, which is equal to, now observe the numerator very carefully, e raised to power x and minus e raised to power x and minus e raised to power x will get cancelled. Remaining term in the numerator is e raised to power y. In the same way, in the denominator, e raised to power y, keep it as it is, multiply by minus to both the terms in this bracket. So here we will get minus e raised to power x, and minus into plus will be minus e raised to power y. So which is equal to, from the denominator these two terms will get cancelled. So e raised to power y upon minus e raised to power x will be the remaining term, minus keep it as it is, and here we are again applying laws of exponent, means laws of indices, घातांकाचे नियम ज्याला म्हणतो आपण, e raised to power y divided by e raised to power x will be equals to e raised to power y minus x. If base are same, in case of division we are taking subtraction of the power, and this is nothing but the value of what, dy by dx. In this way we have got our required value of dy by dx. Now see the question number 5. In this question, one function is given to us sine inverse of x raised to power 5 minus y raised to power 5 divided by x raised to power 5 plus y raised to power 5 is equal to pi by 6. Using this, we have to show that differentiation will be equal to x raised to power 4 divided by 3y raised to power 4. So first, by taking sine on both sides, here on the left hand side we are able to eliminate sine inverse. So which property here we are applying, that sine inverse of x will be equals to what, x, means in short sine and sine inverse will get cancelled according to one of the property of inverse trigonometric function. Means if you are taking sine on both sides, on the left hand side sine and sine inverse will get cancelled, remaining term is x raised to power 5 minus y raised to power 5 divided by x raised to power 5 plus y raised to power 5. And since we have taken sine on left hand side, so we are taking sine on right hand side also. So sine pi by 6. But we know that value of sine pi by 6. What is sine pi by 6? Means sine 30 will be equal to 1 by 2. On the right hand, on the left hand side, keep these terms as it is. X raised to power 5 plus y raised to power 5. Now let us simplify. 2 will get multiplied. So on this side we will get 2 into x raised to power 5 minus 2 into y raised to power 5, and on this side 1 into multiply by this denominator to 1, we will get x raised to power 5 plus y raised to power 5. Okay. Now on one side we are collecting the terms of x, and on another side we are collecting the terms of y. So therefore here 2x raised to power 5, keep it as it is, this plus term on this side will become minus x raised to power 5, and on this side y raised to power 5, keep it as it is, this minus term on this side will become plus 2y raised to power 5. Now let us simplify. 2x raised to power 5 minus x raised to power 5 is x raised to power 5, and on this side y raised to power 5 plus 2y raised to power 5 will be 3y raised to power 5. Now we are differentiating it with respect to x. So differentiate it with respect to x. On this side derivative of x raised to power 5 is 5x raised to power 4, and on another side 3 is a constant term, keep it as it is, derivative of y raised to power 5 is 5 into y raised to power 4 into derivative of y raised to power 4 is derivative of y is dy by dx, because function is in the form of f of x raised to power n. First take power as an coefficient, then decrease power of f of x by 1, then derivative of f of x. F of x is nothing but y. If you will observe both sides, 5 and 5 on both sides will get cancelled. On this side remaining term is x raised to power 4, and on this side 3y raised to power 4 dy by dx. So simplify it to find out required value of dy by dx. So this term will get divided on this side, means on this side we will get x raised to power 4 divided by 3y raised to power 4, which is nothing but our required value of dy by dx. See the example number 6. In this example, what is the given function? X raised to power y is equal to e raised to power x minus y, using which we have to show that value of dy by dx is equal to log x upon 1 plus log x whole bracket square. Okay, so first we have considered the given function. Let us simplify it, and finding differentiation we will try to get our required result. If you will observe the left hand side, observe this function is in the form of f of x raised to power g of x. In such cases we are applying logarithmic differentiation method, means we are finding or we are solving this example by taking log on both sides. So taking log on both sides, see on left hand side what we will get, log of x raised to power y, and on the right hand side log of e raised to power x minus y. According to laws of logarithm, this power can be taken as coefficient, that is y into log x, and on the right hand side take this power x minus y as an coefficient into log e. So y into log x, keep it as it is. On this side replace log e by its value 1, because we know that value of log e will be equals to 1. Since we have to find out value of dy by dx, on one side we are collecting the terms of dy by dx. So minus y on this side will become plus y plus y log x is equal to, remaining term on this side is x. If we are taking y common from both the term, here we will get 1 plus log x. On the right hand side x, keep it as it is. So this implies that y is equal to x divided by 1 plus log x. Now if you as is here also we are able to differentiate it with respect to x, but we have simplified this function in this form, because if you observe the result, in the result denominator is what? Square of 1 plus log x, and such type of result we will get in case of what? Quotient rule. That if we are applying quotient rule, at that time denominator is what? V square, means if the function is in the form of y is equal to u upon v, in the differentiation denominator is what? V square. That's why we have tried to get 1 plus log x in the denominator, so that after applying quotient rule we will get square of this term in the denominator. Hope it is clear to you. Now let us differentiate it with respect to x. So differentiate it with respect to x. So derivative of y with respect to x is dy upon dx. On the right hand side, let us see what we'll get applying quotient rule. According to quotient rule, v as it is means 1 plus log x as it is, 1 plus log x, v as it is into derivative of u means derivative of what? X, minus v as u as it is means x as it is, into derivative of v means derivative of 1 plus log x, divided by square of v. Square of v means square of 1 plus log x. In this way we have substituted just the values in the quotient rule. Now simplify it. So 1 plus log x, keep it as it is, 1 plus log x as it is, derivative of x is 1, minus x as it is, here derivative of 1 is 0 because 1 is constant term, and derivative of log x will be equal to 1 by x. In the denominator 1 plus log x whole bracket square, keep it as it is. Now let us simplify the numerator. 1 into 1 plus log x is 1 plus log x, and here not necessary to write 0. 0 plus 1 by x will be equals to 1 by x. In the denominator 1 plus log x whole bracket square, keep it as it is, here x and x will get cancelled. So 1 plus log x, here remaining term is what? Minus 1, isn't it? And in the denominator square of 1 plus log x, keep it as it is. Now in the numerator plus 1 and minus 1 will get cancelled, remaining term in the numerator is log x, and in the denominator see what we'll get? 1 plus log x whole bracket square. In this way we have got the value of what? Dy by dx, and here we can observe that this is nothing but required value of dy by dx. Now see in the example number 7, what is the given function? Y is equal to under root cos x plus under root cos x plus under root cos x plus continuing up to infinity, means such type of infinite terms are there, using which we have to show that value of dy by dx is sin x upon 1 minus 2y. So let us consider the given function here. So first we are squaring both sides. If such type of example appears at that time, if root appears, so in such cases to eliminate first root we are squaring both sides. Let us see what we will get if we are squaring on both sides. So on this side we will get y square, and on this side this root will get eliminated, means what is the remaining term? Cos x plus under root cos x plus under root cos x continuing this way up to what? Infinity. Let us denote this equation say by equation number first. On this side y square keep it as it is, cos x also as it is, plus also as it is. This result we have got simply by squaring both sides. Now if you observe this expression, can I say that this is nothing but value of y? This whole expression, if you observe this expression, will be the same one, and which can be replaced by y from equation number first. So we are substituting its value is equal to y. This value we are substituting from equation number first. Now the function is in the simplest form, so let us differentiate it. So differentiate with respect to x. So derivative of y square is 2y, dy by dx. First we have taken power of y as an coefficient, decrease its power by 1, then derivative of y is dy by dx. On this side derivative of cos x is minus sin x, and derivative of y is dy upon dx. So collect the terms of dy upon dx. How many terms of dy upon dx are there? 2 terms. So which is equal to, on this side minus sin x, keep it as it is. So here its coefficient is 2y, and here this plus term on this side will become minus. So minus 1 if we are taking dy by dx common. So we have collected the terms of dy by dx and we have taken dy by dx common from both the terms. So which implies that value of dy upon dx will be equals to, what is the what we are getting in the numerator? Minus sin x, and in the denominator, because this term is multiplied, on this side it will get divided, so in the denominator we will get 2y minus 1, which implies that dy upon dx is equal to, now in our required result minus is not there in the numerator. To eliminate this minus, we are multiplying to numerator and denominator by minus. So if I am multiplying to numerator by minus, so here we will get sin x, and since we are multiplying to numerator by minus, that's why I multiplied to denominator also by minus. If I am multiplying to denominator by minus, this minus 1 will become plus 1 and plus 2y will become minus 2y. In this way we have got the value of what? Dy by dx will be equal to sin x upon 1 minus 2y, which is nothing but our required value of dy by dx. See the example number now 8th. In this case given function is y is equal to under root log x plus under root log x plus under root log x, continuing this way up to infinity. Using this we have to show that value of dy by dx is equal to 1 upon x into 2y minus 1. Now here also we are using the same method which we have applied in the last example. So first we will try to eliminate first root by squaring both sides, square on both sides. Let us see what result we will get here by squaring on both sides. So derivative square of y is y square. If we are squaring on this side, this first root will get eliminated. So remaining term is log x plus under root log x plus under root log x, continuing this way up to what? Infinity. Let us denote this expression by equation number first, which is our given function. So now here y square keep it as it is, on this side log x also as it is, plus. Now this whole expression, is it the same one? So if it is the same one, then from equation number first it can be replaced by what? Y. So I am replacing this whole expression by what? Y. So now we are differentiating it with respect to x. So differentiate with respect to x. What is derivative of y square? 2y dy by dx. Derivative of log x will be 1 by x, and this derivative of y will be equal to dy by dx. How many terms of dy by dx are there? 2 terms. We are taking dy by dx common from these 2 terms. If we are taking dy by dx common from first term, here its coefficient is 2y, और ये plus term इधर आके क्या होगा? Minus, and if we are taking dy by dx common, so its coefficient is minus 1. On this side 1 upon x, keep it as it is, which implies that dy upon dx will be equals to, in the numerator 1 keep it as it is, in the denominator x as it is. This term will get divided on this side, means in the denominator will get 2y minus 1. Check that, is it our required value of dy by dx? So yes, 1 upon x into 2y minus 1 will be our required value of dy by dx. Now see the example number 9th. In this example, given function is y is equal to x raised to power x raised to power x raised to power x raised to power x, continuing it till up to infinity. Using this, we have to show that value of dy by dx is equal to y square divided by x into 1 minus log y. So let us first simplify this function and later on we will differentiate it. So here y can be written as, so y will be equal to x raised to power, x raised to power, x raised to power, here x raised to power up to what? Infinity. Here x are going on what? Continue. Will get continue. So therefore y is equal to, keep this x as it is, and if you observe this whole expression, is it in this form? Yes. And which can be replaced by what? Y. From which equation? First. This value we are substituting from equation number first. Now here easily we can observe that the term on the right hand side is in the form of f of x raised to power g of x, and to find out differentiation of such type of function we have to use logarithmic differentiation method. Means we have to solve this example by taking log on both sides. So taking log on both sides, see what we will get here after taking log on both sides. On the left hand side we will get log y, and on the right hand side log of x raised to power y. According to laws of logarithm, this power can be taken as coefficient, so here we will get y log x, on this side log y, keep it as it is. Let us differentiate it with respect to x. So see, on the left hand side derivative of log y is 1 upon y dy upon dx, and on the right hand side keep first term, means y as it is, into derivative of second term. Derivative of second term means derivative of log x, plus second term as it is, means log x as it is, into derivative of first term. What is first term here? Y, means derivative of y. Just we have applied product rule to find out differentiation of this left hand side. Now let us simplify it. So 1 upon y, keep it as it is, dy upon dx also as it is equals to y as it is. What is derivative of this log x? Derivative of log x will be equal to 1 upon x plus log x dy by dx, keep it as it is. Now differentiation of every term is taken here. Now we have to collect the terms of what? Dy by dx. How many terms of dy by dx are there? 2 terms. So we are taking dy by dx common from these 2 terms. So here its coefficient is 1 upon y, and this term is plus. On this side it will become minus log x dy by dx. Dy by dx we have taken common from both the terms. Remaining term on this side is y by x. Y into 1 by x is y by x, isn't it? Now on this side take the cross multiplication, 1 minus y log x divided by y into dy by dx is equals to y by x. Just simply we have taken cross multiplication, so which implies that value of dy upon dx will be equals to, on this side y keep it as it is, in the denominator x also as it is. Sorry, here y will get multiplied on this side, y into y will become y square, और ये जो न्यूमरेटर है ये इधर आके क्या होगा? डिवाइडेड. So 1 minus y log x, so which is equal to, in the numerator y square keep it as it is, and observe the denominator x into 1 minus, but instead of y log x here log y is there, means we can observe that y log x is replaced by what? Log y, and this value we are able to substitute from this equation number 2. Y log x can be replaced by what? Log y, means this y log x we are replacing by log y from equation number 2. In this way we have got required value of dy by dx. Now see the last example from this exercise also and from this question also. In this case given function is e raised to power y is equal to y raised to power x. Using this we have to show that dy by dx is equal to square of log y divided by log y minus 1. So let us try to get our required result. If you will observe the given function, on the right hand side term is in the form of f of x raised to power g of x. In such cases we are applying logarithmic differentiation method, means we have to solve this example by taking log on both sides. See what we will get here. On this side we will get log of e raised to power y, and on this side we will get log of y raised to power x. Now we are simplifying it applying laws of logarithm. So first take this power as an coefficient, so here we will get y log e, and on this side if we are taking power as an coefficient applying laws of logarithm, we will get x log y. We know that log e is equals to 1, so replace it by 1 on this side, x log y, keep it as it is. Now we are differentiating it with respect to x. So differentiate it with respect to x. Derivative of y is dy upon dx is equals to, now on the right hand side, to find out the differentiation we have to apply product rule, because product of two function is there. According to product rule, keep first term as it is, derivative of second term is derivative of what, log y, plus second term means log y as it is into derivative of first term is derivative of x. So dy upon dx, keep it as it is. On this side, x as it is. What is derivative of log y? Derivative of log y is 1 upon y into dy by dx, because it is in the form of log f of x. So its differentiation is 1 upon f of x into derivative of f of x. F of x is what here? Y. So derivative of y means dy by dx. On this side, log y as it is, derivative of x will be equals to 1. So we have taken differentiation of every term. Now we are collecting the terms of dy by dx. Two terms of dy by dx are there. If we are taking dy by dx common from these two terms, so here its coefficient is 1 and here its coefficient is x upon y. X into 1 is x upon y. On this side will become minus x upon y. Dy by dx we have taken common from both the term. Remaining term on the right hand side is log y. So dy upon dx will be equals to, take the cross multiplication here, we will get y minus x upon y is equals to log y, isn't it? Now this y will get multiplied on this side. So y into log y, so dy upon dx will be equals to, see what we are getting, log y into y divided by y minus x. In this way we have got our required differentiation. But if you observe here, such type of function or such type of, this is not our required result, isn't it? We have got value of dy by dx, but required result is somewhat another. So means we have to simplify it. To simplify it, we are replacing here. If you observe that required result, in this required result x does not appear, means we have to eliminate this x, and to eliminate this x we are making the use of this equation. Let us denote this equation by equation number first. So which is equal to y log y, keep it as it is, divided by y as it is minus x. What is the value of x here? Y upon log y. So this value we are getting from equation number first. So from first, okay, so which is equals to, now I am multiplying to numerator and denominator by what? Y. So log y, let us see what we'll get here. Y multiply first to numerator by log y, so here log y into log y is square of log y, and if we are multiplying to denominator by log y, so here we will get y log y minus, if I am multiplying to second term by log y will get cancelled. This result we have got simply multiplying to numerator and denominator by log y. Now if we are dividing to numerator and denominator by y, because every term contains y, so if I am dividing to numerator by y, in the numerator after cancelling y, remaining term is log y whole bracket square. Now since we are dividing to numerator by y, that's why we are dividing to denominator by y. So divide to first term by y will get cancelled, here we will get log y minus, here we will get 1 if we are dividing by what? Log y, and check that is it the required value of dy by dx? Yes. So in this way we have got required value of dy by dx. So in this way we have completed all the example from this exercise 1.3. In the next video we will start next article from this chapter, that is derivative of parametric function. So if you think that these videos are helpful to you, so please like the videos and share these videos with your friends also.